Good afternoon, grade 4s, and welcome to Natural Science Week 9. Can you believe it? Week 9 already. My name is Mrs. de Klerk, and I am your natural science teacher. I see a lot of you in the chat box just asked me if we are doing Kahoot today. Not today, tomorrow. Today's Thursday. So we'll finish up some of the work we've been doing today. Tomorrow we will play Kahoot. And the questions I'm going to ask you in Kahoot is about all the things that I have taught you in the last couple of weeks, the last 3 weeks. Okay, so it's all the revision you did on term 1, about plants, about habitats and animals, and then also this week's lesson about materials. Okay. Now, if we had to recap on yesterday's lesson, I see it says Tuesday there. It's supposed to be Wednesday. We looked at materials around us. Now, we looked at change of state, and we looked at what causes change of state. We spoke specifically about melting and freezing. Today, we will look at the change of state, what causes change of state again, but this time we are going to look at heating and cooling to cause a change of state. Remember the states? Liquid, solid, and gas. Okay, now we are going to look at heating and cooling to cause a change of state. If we had to do an experiment using boiling water in a kettle and a mirror or a glass, I'm going to explain the experiment to you, then we can see a change of state taking place through condensation. I'm going to explain all of that just now. We obviously cannot do this experiment with each other or in one class, and we obviously also can't do it over the internet. So you have to imagine, okay. Now, please do not go and do this on your own because you can burn yourself if you're not careful. The steam is hot, and this has to do with a boiling kettle. Okay, now, if you put a glass or a mirror 30 centimeters above the boiling kettle, then you are going to see a state of change, change taking place. Like in the picture, I'm pulling over my words here. In the picture here, what I mean. So you have a boiling kettle, which is steaming, and you place a mirror above it. What is going to happen here? What will happen to the mirror? And that is what we are going to look at now. Now, the change of state when the water boiled becomes steam is water to gas, and that is called evaporation. But this specific experiment is not going to be about evaporation. It's going to be about condensation. We are going to speak about the difference between the two as well, okay? You cannot actually see the steam. The steam is extremely hot and it quickly cools, but then it forms tiny droplets in the air. And that is what you see, the white cloud that you see. Now, when the steam changes into tiny water droplets, that is called condensation. Okay, so condensation is when the gas turns into the liquid. Evaporation is when the water turns into a gas. So do not confuse the two. We'll speak about it some more just now. The term evaporation and condensation are both steps in the water cycle. Now, evaporation occurs when a liquid like water is heated and it changes from a liquid to a gas, exactly what you are seeing here. This is evaporation. Condensation occurs when the water vapor cools. Now, as soon as it leaves this kettle, the vapor will cool down and it will change from the gas to water. Like all these are little water droplets. And then it will change back into a liquid. And that is what is seen in this experiment. is condensation. Okay. Let me just see what you guys are saying in the chat box. Yes, you guys are right. It will turn into a liquid. Okay. Evaporation and condensation. The reason why I'm hammering on this is a lot of students get confused with the two. Now remember that, and I'm going to try my best to explain the difference to you guys so that you will be able to remember. Evaporation takes place when heat is added to the liquid. So you can think of the water being boiled. Evaporation will take place, okay? Please switch off your cameras. Those cameras that are on, please switch them off because they are covering my screen. Okay, it means that the water changes from a liquid to a gas. Again, think about boiling water. If you add heat to the water, the liquid is going to turn to gas. Even clothes that you hang out to dry, wet clothes that you hang out to dry in the sun, they dry as the water evaporates because you're adding heat from the sun. That water will turn into a gas. Okay, that is what happens to clothes when you hang them up. Now let's go back to the experiment of the steam. The steam that comes out of the kettle, like we've already said, is extremely hot and you cannot really see the steam. Okay. The steam quickly cools. As soon as it leaves the kettle, it cools and it forms tiny droplets in the air, and these tiny droplets are visible and they form the cloud that you see. So all of this white cloud is tiny droplets that it's starting to form because the gas is now colder. It goes from hot to going into the air that is colder than where it came from. Okay, so that is the cloud that you see. That is, I just want to change my highlighter. All of these. Okay, this is tiny droplets of water. When these tiny droplets hit the mirror, they cool more and they form bigger droplets, which you can then see on the mirror. So here they are still very small. But on the mirror itself, it's going to look like this because now they become bigger. They cool even more. The higher it goes, or the longer it is in the air, the faster it will turn into this. Okay, now that is condensation. We say that steam condensed to form water. Do you see the difference there between the evaporation and the condensation? Evaporation, when heat is added and the liquid turns into a gas. Condensation is when the gas, heat is taken away and the gas turns back into a liquid. Let me just see your chat box quickly. Okay, this is something that you will see in the shower. If you shower and it is very hot and you look at the mirror, you will see tiny droplets. So that's condensation, okay? Now the change of state is from gas to liquid. Remember, it's the gas that cools down, it turns back into liquid, and that is called condensation. So condensation takes place when heat is removed. Evaporation takes place when heat is added. Okay. When you leave a glass filled with cold water on the table, small droplets form on the outside. You guys know if you have a nice, very cold Coke that you took out of a fridge at some shop and you put it on the table outside, especially when it's a really nice and hot day, then when you pick up that Coke, it will be wet and you will feel the droplets on the side. That is exactly that. It's because there's water vapor in the air which cools down, and then it's near the cold glass or then the Coke can. The water vapor in the air around the glass condenses, as it changes from a gas to a liquid, and it forms the tiny droplets that you can see, like there. Water droplets on the outside of cold glass. This is my friend Vusi, and Vusi says, we now know that substances react to temperature changes around them. Have you noticed that yesterday as well? In the story we read, that the melting and the freezing all had to do with temperatures around it. It's the same here. So substances react to temperatures that changes around them. Now let's quickly speak about melting and solidifying substances. Yesterday, I told you what solidifying substance is. If you were not there, that's fine. It's not a problem. To demonstrate melting and solidifying substances, we are going to look at a recipe for making ice cream. And then we are going to answer some questions about it. So I hope all of you have already eaten and that you're not sitting in this class really hungry, because later on chocolate is also mentioned. So I am already making plans in my head to go buy either an ice cream or a chocolate after this class, even though it is a little bit cold outside. So let's quickly look at this. Okay, here is how you make ice cream. Now I just want us to read through the ingredients and how to do it, because I'm going to ask you some questions about this, okay, afterwards. And so we have to know what goes in it. But if you want to go make your own ice cream, quickly take a screenshot or take a photo of this slide, then you can go try and make your own ice cream at home. Okay, let's look at the materials that you will need. You'll need an electric blender, a 2-liter container with a lid, 3 ripe bananas, 2 cups of fresh cream, 2 cups of milk, a teaspoon of vanilla essence, and half a cup of sugar. Now, as I read these ingredients, already think in your head which of those are solids and which of those are liquids, because in this experiment, we're going to see what changes here. Okay, what change of state takes place. Now, the instructions tell us we can watch a video, but we can't do that right now. So we are just going to look at the instructions. Okay, let's read number 2. To make the ice cream, cut up the 3 bananas into pieces. So this is obviously going to be banana ice cream. Put the bananas into the electric beater. Again here, think in your mind, what state is a banana? Is it a liquid or is it a solid? Pour the fresh cream and the milk into the blender. Again, see it in your mind's eye and quickly think if fresh cream and milk is a solid or is it a liquid. Also do the same with the vanilla essence. That's the next ingredient. Add the vanilla essence and then add the sugar. So also think about sugar. Is it a liquid or is it a solid? Then look at number 7. You can add any other flavors you may want into the ice cream, such as, and here we go, chocolate pieces or strawberries. Both of the things that I love. So this should be a very nice ice cream. Banana, chocolate, and strawberries. Yum. Number 8, plug the blender in and turn it on. And don't forget to put the lid on. I'm going to say it again. Don't forget to put the lid on. And the reason why I want to shout it to you is because I've done that before. And believe me, it's not fun washing milk and cream and bananas out of your hair or having to clean the roof. Well, I mean the ceiling or the floor for that matter. Okay, so put the lid on when you put something in a blender. your homework. Yes, you can go make this and I'll ask you some questions to write down. Then for about 1 minute, pour the mixture into a 2-liter container. So you see now this is going to make 2 liters, okay? Place the lid on the container and place the container in the freezer for the night. So you can use an old ice cream container that your mom has in the cupboard there. Enjoy your ice cream the next day. So you guys are more than welcome to go and try this. You can tell your parents it's a school experiment. Then go try this and you can come and answer some questions and see how change of states take place, okay? So could you take a screenshot? Did you guys do? Did you do it? Oopsie. No. I'm sorry, guys. Can you see the screen? I just changed something here by accident. So you all can see the screen with the activity on, right? Okay, next page. Here is our question. The ingredients were in different states, solids or liquids, before and after making the ice cream. Can't you guys see? Can you see the screen that says it has questions, ingredients before and after on it? Do you see that screen? No. What do you guys see? Is it still on the first slide? Oh no. What do you see in front of you? Okay. Quickly, I'm going to share it with you again. Can you see it now? What slide do you see? Still not. Oh no, I've done something wrong here. Oh no. Can you see it now? Still the first slide. Can you see it now? Oh my goodness. I have not seen anything that I've showed you. Okay, you can see it now. Did you see the previous slide with the ingredients on? Not. I'm going to go back. These are questions here. I'm going to go back to the first slide. Did you guys? Okay, now I'm going to ask you, do you see the very first slide in front of you now? Okay. Now you see my face? Okay. I think we are on the right thing now. I don't know what I did there. That was a very big technical problem from my side. I'm sorry. So what did you guys not see? Did you see the recipe? Did you see this, the kettle? Okay, so you basically saw everything until I had that little finger slip. Let's see. You saw all of this. I'm so sorry, guys. You saw Vusi. You saw this screen, right? Okay. The recipe. Thank you for helping me, you guys. I would have just continued teaching you and you would have seen nothing and I see everything. Thanks for helping out here. Okay. We were speaking about how to make this ice cream. Now we are going to look at different states. The ingredients were in different states, a solid or a liquid, before and after making the ice cream. We are going to use the table below to record which state each ingredient was in before and after making the ice cream. Okay, you guys are going to tell me the answers. I didn't write the answers in for you because you are my smarty class. I know you can do this. So the bananas, before we made ice cream, was it a solid or was it a liquid? Quickly type in your chat box. Was it a solid or was it a liquid? Solid. Good. So all of you unanimously agree it was a solid. Now, after, or let's do fresh cream first. Fresh cream, is it a solid or is it a liquid? Liquid. Good. Great. You are right. Cream is a liquid. Milk, is it a solid or a liquid? Milk. Liquid. Fantastic. Smarties. Vanilla essence, solid or liquid? It's a liquid that smells really, really, really nice. Sugar. Is sugar a solid or a liquid? Solid, solid. Good. Okay, so you guys really understand the difference between solid and liquid. That's quite easy. Now I want to know, how did it change? Did a banana change from before to after? I know that the shape changed. Okay, but I want to know, is it still a solid now? It's still a solid. Good. Okay. The next one. Before it was a liquid, and now, what is it now? Now when it's ice cream, did it change? Remember, the fresh cream is now frozen. It's ice cream now, and ice cream is a solid, yes. So the fresh cream changed from ice cream, from fluid to solid. Good. The milk, it changed, right? The milk also changed from liquid to solid. The vanilla essence, the same. And the sugar, it was a solid, and after, still a solid. Good. So the banana was solid, after still a solid. The cream and the milk and the vanilla essence was liquids, after they were solids. The sugar was a solid, and after it remained a solid. Okay. Now you have to answer questions that we've actually just answered already. But first I want to know if anyone can remember, what do we call the process when a liquid changes to a solid? What do you call that? When a liquid changes to a solid? You can tell me. This is where, yes, it will first change into a liquid, but remember, then we are freezing it. So everything that we put in the blender will first be a liquid, but if you put all of that in the freezer and it makes ice cream, then it is going to be a solid. Do you understand? Neo, you have the right answer. The scientific name I'm looking for, what we call the process for when a liquid changes to a solid, you can think of ice cream here. Ice cream was first a liquid, it changes to a solid, we call it solidifying. Okay, remember that word, solidifying. Then which ingredients changed state? The three ingredients that we mentioned that were liquids before the time, but solids afterwards. Can you remember those three? Milk, the other two? Milk, not sugar. Sugar was a solid, remember? Milk and cream and vanilla essence. Good. Cream, milk, and vanilla essence. Okay, now we're going to look at another experiment to demonstrate melting and solidifying substances. Okay, this one. You'll see on the picture what they did and what is supposed to happen here. We have a candle that obviously is lit, so it is hot. you'll see that they didn't use their hands because they'll obviously burn. So we have a tin, and inside is chocolate or any substance that we can melt and also solidify. And then we have the wooden pegs to hold it with, because the tin will obviously get hot. Right. Now, what would happen to the following substances if we had to place them over the candle and then remove it again and put it on the side to cool? So if you put butter or margarine in a tin and you hold it above a candle like that, what is going to happen to it? Can you quickly answer me in the chat box? It will melt, yes. Zoe and Kwanda, yes, you guys are right. Sandy as well. Yes, Neo, yes. Okay, all of you are saying melt, good. Now, what would happen to chocolate or to candle wax if you had to put it, well, even the wax on the candle? Yes, it will turn into oil, it will melt, it will get hard. Not immediately, it will first melt. Good, most of you are saying it will melt, you are right. If you had to put the chocolate above, and this is what is in here, or above the candle, the chocolate is eventually going to melt. It might just take a little bit long, depending on how cold the chocolate was. The wax, remember, you see where my highlighter is here? Usually there, it becomes a liquid, like an oily type of liquid. And then when you put out the candle, that liquid will sit here on the side and it will solidify again, like that. But while it is burning, it becomes a liquid, and it will actually run down the candle, or maybe at the bottom. You all know that because you've all done this. Now, if you had to put an ice box, yes, it's called wax, yes. If you had to put an ice box or ice cream in the tin above the candle, what will happen to it? So Seku, you don't have to use an electric blender for the ice cream. If you have one, it would be good, because it's difficult to smash the banana. Listen, guys, I just have to warn you. If you hear a shout and a scream from me, there is a red wasp very close to me on a window, and I'm very scared of it. So don't get a fright if you hear me scream. It just means it's attacking me and I am running for dear life. Okay, now that you guys know that's what's going on here in my house, my office, let's try and continue with this lesson. Woo, this is very scary to me, so you guys have to bear with me, okay? Now the ice in the box or the ice cream will melt very, very quickly, quicker than the rest. Let's see, we have to fill in this table. You see here is the butter and the margarine. Now before heating the butter and the margarine, what state was it? Before we melted it, what state was it? Can you quickly type in your chat box? A solid, good. Good, it was a solid. Now what happens to it after heating? It turned into a, can you type in your chat box? It became a liquid, good. Very good. Now, if you had to take it off the candle again and you had to place it next to it, what will happen to that margarine eventually in a couple of minutes? Will it stay a liquid like that? Or what is going to happen? Can you type in your chat box for me? It will turn back into a solid. Did you know that? Not in the same shape. If you melt butter, even on a stove, and you take it off again, and you come in back in a little while, that would have solidified. Now I have good news for you. Someone has just come to my rescue and they are coming to remove this wasp. Then I can breathe again. Okay, there it's gone. Thank goodness. Thank you for sticking here with me, guys. Okay, so that butter that was a solid before has turned into a liquid when you added heat. But if you take it away from the heat, it becomes a solid again. Now, the same will happen to chocolate. The chocolate was a solid before, but now when you heat the chocolate, it will turn into a liquid. It will melt. If you take the chocolate away and you put it next to it for a little while, what will happen? It's going to turn back into a solid. Now, if you think about it this way, if you buy a chocolate, or when you buy a chocolate, you're at the shop and you leave your chocolate in a hot car, it is going to melt. But if you take that chocolate out of the car and you put it in your house, especially if you put it in a freezer, it will become hard again. Just the shape will change, but it will solidify. Okay, now let's look at the ice blocks. Before heating, it was in which state? Quickly type in your chat box, which state was it before we heated it? It was a solid, right? Now what happened when we heated the ice blocks or the ice cream? It turned into a liquid. And then if you put it next, the other one solidified, will ice cream solidify? No, ice cream is going to stay a liquid. Shakira, very good. Ice cream will only turn into a solid if you put it in the freezer. Absolutely right, 100% correct. Ice cream needs to be at a colder temperature than the butter or the chocolate in order to solidify. So again, you see, we are working with temperatures here. And this is because it has a different freezing temperature. Okay, so it works a little bit different. So what happens when the solids are heated by the candles? They will melt. And what will happen to the substances when they have cooled down again? Can you quickly name in your chat box what will happen to them when they cool down? They will, what's that word I'm looking for? Become a solid, well, the word is solidify, solidify. So you will write solid and just write a phi next to it, solidify, okay? Except the ice cream. The ice cream will not solidify. It will remain a liquid. Naledi, very good. Because you are saying the freezer freezes at 0 degrees. Ice cream should not have solidified again if it was not placed back in the freezer. Okay. Karen, you say you are going out of the class because your mom's iPad is about to die. Please remember we are playing Kahoot tomorrow, okay? You're almost done with class and then I will speak to you a little bit about Kahoot. Let's quickly speak about adding and removing heat, like on the experiments that we just did. We have seen that solids have melted can be solidified again. So the process can be reversed or turned around again by adding or removing heat. You see that adding and removing heat has a lot to do with the changes, or everything to do with the changes of state. Like chocolate, like I just explained to you, when you have chocolate that melted in the car, it will melt on a hot surface. Okay. Let's see what we've learned from yesterday's story of Mashadu and the activities we looked at today. Now we have learned some new big words and some of them might be confusing, like solidify, but let me quickly show you a summary of the different states. You can see a solid to a liquid. If something will change from a solid to a liquid, and we call this process melting. Okay. We can change a liquid to a gas by heating, and we call that evaporating or evaporation. Next one, gas to a liquid. By cooling it, condensation will take place, condensing. Then here, a liquid can be turned to a solid by taking away heat, by cooling it, and that is freezing or solidifying. Okay, so you guys understand all the different processes. Melting, evaporating, condensing, or freezing and solidifying. Every time it is either heat added or taken away, where it cools down and it will change from one state to another. Okay. It would be good if you took a screenshot of this page because this will help you to remember this, okay? Now remember, freezing requires specific conditions. It requires 0 degrees Celsius. Now temperature. You've seen now in the previous activity, we are able to melt and solidify different substances. Some of these substances may have taken longer to melt than others. Now the ice cream probably melted the quickest, but the chocolate took longer. Now each substance starts melting at a certain temperature. Now when it starts melting, we call that the melting point of a substance. Temperature is measured in degrees Celsius with an instrument called a thermometer, which I think you are all very familiar with. This is a thermometer to measure the temperature of air. Now, this table shows the melting temperature of different substances. Okay, so at 0 degrees, ice will start melting. Chocolate at 32 and wax at 62 degrees. Okay. Now, if we look at which substance melts at the lowest temperature, which substance melts at the highest temperature, what is the name of the process when solid wax turns into a liquid, and what do you need to change a liquid gas into a solid again? Let's get those answers. And then the last one, what process is the reverse of melting? Remember these questions because I will be asking them in Kahoot tomorrow. As if there are any cameras on, please switch them off. You are blocking the screens for all the students to see properly, okay? Now, which of those substances melts at the lowest temperature? It was ice. Which one melts at the highest temperature? It was wax. What is the name of the process when solid wax turns into a liquid? Can you guys remember? Melting. Just think about it logically. When wax turns to a liquid, it's melting. What do you need to do to change liquid gas into solid again? You need to cool it down. If it cools down, it will turn back into a solid. And the process of the reverse of melting is solidifying. So that's the opposite. There are two opposites, melting and solidifying. Okay, you got it. Yes, wax was the highest temperature. Okay, you guys are more than welcome to contact me with any questions. You can go try making that ice cream and see what can solidify and how liquids can turn into solids and all of that. Okay, I quickly just want to speak to you guys. Oh, can you still see my screen? Something very strange is going on with my screen here. What are you guys seeing? I wanted to show you the game. It's not on this slide. Okay, you just see back. Oh my goodness, something is wrong with my screen here. Right, guys, we are at the end of our lesson. But tomorrow we are going to play Kahoot. Sorry about this today. We are going to play Kahoot tomorrow. If you have a second device, then please bring it with you. I will send you the code that you need to type in, okay? We'll play on Kahoot.it. I will tell you again tomorrow. I'll give you a code and then we are going to play Kahoot. I'll see you guys tomorrow. And thank you so much for joining me today. Have a fantastic day. And look forward to our game tomorrow, okay? Bye-bye, guys.